So this is the 5.4 fundamental theorem of calculus. So this is the basics of integration or the antiderivative. We're not going to go into details until chapter 6. So chapter 6 goes more into detail about doing the integration and different rules. But we're just going to do the basics to this. So the basic concept is that we're going to take the integration of something like this, the integration of 1 to 2 of x dx. And the exponent, when we did the derivative, we brought the exponent down and then we subtracted 1. So the antiderivative now goes backwards. We're going to add 1 instead. So in this case right here, I would have is then x squared, right? Because this is a 1 right there. If I add 1, it'll be 2. But we also divided by the same number on the exponent. So if this is 2, this is 2 as well. Okay? Now, if there was no limits right there, we would put plus c and you would be done with the problem. But since we have limits of 1 and 2, we're actually going to have to substitute in the limits right there. So the limits then from 1 to 2. So we write it up something like this, and then we substitute it in. So then I have is 2 to the second power gives us 4 over 2, and then minus. Now this is always a minus on the operation, and then we're going to put in 1 squared right there, which is half, right? And then if we put those together, that should give us 3 over 2 as your final answer. Okay? Now the next part. We're going to take the integration from 0 to 1 of the cube root of x squared. Now I'm going to fix this up and just make it easier, just like when we did the derivative. Whenever you had something like this, we always wanted to put into the polynomial form. So this is our in and out, right, all over this. Now notice I still have my integration symbol because I did not take the integration. All I did was basically reset this equation up. Just like when we did the derivatives, you just left it as y equals. If you did not take the derivative, you're just touching up or doing some algebra to it. Okay? So now let's actually go ahead and take the integration. So we're going to add 1, so that's the 3 over 3. So that's going to give us an x to the 5/3, right? And then from there, we're going to multiply by the reciprocal of this. Because you would normally divide it by 5/3, but then that's the fraction over fraction, which we don't like. So if you multiply by the reciprocal, it makes it easier for us. So whatever this is right here, just do the reciprocal of it on the other side. So now we put in the limits of 1 and 0. So let's do the substitution now. So 3 over 5, 1 to the 5/3 right there, minus 3 over 5, 0 to the 5/3. Anything 0 is going to give us 0. And then right here, 1 to any exponent is also 1. And that's going to give us then 3 over 5 is the final answer right there. Okay? Now let's try the next one. So, and again, chapter 6 will go more into detail about how to do, because remember in chapter 3 when we did the derivative, we would do the chain rule, and that was more detailed than the basics. So same thing with the integration. This is going to be the basics. We're not doing anything else after that. So we'll do that more in chapter 6. So let's just go do the basics, which is algebra now. And the algebra now means then I would take this x plus 1, and I would distribute it out. So we have as the distribution x squared plus 2x plus 1, right, dx. And then from there, we're going to go ahead and take the integration. So again, I did not do the integration on this one. I just did the algebra now. So just basically distributed that right there. That gave us this. Now let's take the integration. So it's going to be x to the 3rd over 3 plus 2x squared over 2 plus, and now again this right here is like x to the 0 power right there we have. So when we do the integration, it'll become x to the 1st over 1. And we don't need to put that 1 right there, so that's why I'm not putting the 1 right there. Okay? So now let's put in the substitution. So then if I put in 2, this will give us 8/3 plus 2, and then that's going to give us, what, 4/2 plus 2. That's just for the 2 substitution, minus, and then let's put in negative 1. So that's negative 1/3, because it's negative times negative times negative, right? That's going to give us negative right there. And then if I go negative squared, that's positive. So that's going to give us plus 2 over 2. I know this can also reduce to 1, but because I have fractions right here, I'm just going to leave it as 2 over 2. And then the final one is minus 1 right there. Okay? So now let's distribute the negative. So I'm going to get rid of the parentheses. 8/3 plus 8 over 2 plus 2 plus 1/3 minus 2 over 2 and then plus 1. Okay, so then 8 over 3 plus 1 over 3 gives us 9 over 3. 8 over 2 plus or minus this gives us, what, 6 over 2? And then 2 plus 1 gives us 3 right there. Okay, so now I can simplify. 9 over 3 is 3. 6 over 2 is 3 plus 3. So that should give us 9 as the final answer right there. All right, so now let's do the trig function. So I'm going to introduce the trig functions. So this is, again, called the antiderivative. So you're looking for is the backwards of the derivative. And this is why I had you memorize this in chapter 3. So you have to ask yourself, is derivative of something has to give you secant tangent, which is secant, right? So then the integration of that just becomes secant right there, secant x. And then we have a 0 and pi right there, okay? So now let's substitute. So secant is the same thing as 1 over cosine. So I'm going to go 1 over cosine pi, then minus 1 over cosine 0. And if we do our line right here, pi is on this side right here, 0 is on this side. Cosine owns the x-axis right here, right? So then cosine of pi will give us -1 minus, because of this right here. And then cosine of 0 is 1. So the final answer is -2. Okay? So as I gave a little clue right there, we said that we had to basically take the derivative of whatever this final answer is to give us the integration. So that's how you're going to check your work on this. So let's backtrack and see if we can do this correctly. So basically then, if I took the integration of this right here, which came out to this, if I wanted to check my work, I would take the derivative of this to see if it goes back to the original problem. So let's do that. So let's take this 3 right there. We bring it down, right? That's going to give us 3 over 3 x squared plus 2. And I bring the 2 down, so that's going to be 2x all over 2, and then plus 1, right? Because the integration of, or I'm sorry, derivative of x is 1. So that's going to cancel out. That's going to cancel out. You're left with this x squared plus 2x plus 1, right? Which is then exactly the same as the original equation. That's how you know if you're doing this right. All right, now let's do the exponent one right here. So again, this was the integration right there. So if I take the derivative, I should go back to the original equation, which was right here. So then let's do that. I have this 3 over 5. We're going to bring the 5/3 down. So 5/3 right there, x, and then we subtract 1. So that's going to give us 2/3. The 5 and the 3's all cancel each other out. So you're left with this x to the 2/3, which was the original problem right there. Okay? And then last one right there, so same thing with this one. If I bring the 2 down, right, the 2's will cancel each other out. It becomes x is your final answer. Okay, so that's the way to check your work for the basics of the antiderivative.